All right, welcome everyone. In 1 minute, we will start our Hacky Hour. It's all about the data. So grab your favorite drink or snack and we'll be starting shortly. Hi everyone, my name is Lizzie Alves. I'm in the marketing department here at alwaysAI, and I want to thank you for joining us for Hacky Hour today. We have a great presentation and demonstration in store for you all. Hacky Hour is an event that is designed for our community to share new product releases, do code demos, and have engaging exercises in an interactive format. We will continue to host new Hacky Hours when we have new product releases to share with our community. Feel free to utilize the chat window throughout the presentation to ask questions, and we'll answer them as promptly as we can. If you're joining us for the first time and you're new to alwaysAI, please make sure that you visit alwaysai.co and sign up for a free account to start your computer vision journey today. Today, we're going to be covering how to manage your raw data, enhance it with augmentation, and analyze your data sets. Follow along as we demonstrate synthetic data generation and provide scripts to bounce your classes and validate your bounding boxes. Now I'm going to hand it over to our senior product manager, Todd Gleed, and he's going to kick things off.
Thank you, Lizzie. Welcome, everyone. Today we're going to be talking about data sets. And as Lizzie said, I'm also going to be sharing some scripts with you. These are internal scripts that we use, written by a couple of my colleagues. Lila and Shesh have put some time into these scripts, but they're kind of works in progress. So I've also written a tutorial on how to use these scripts that's going to be published over the next couple of days. So feel free to check back on that. You don't have to take a lot of notes during this. Kind of use that tutorial to help you navigate the scripts after this is done. As far as the agenda, the first two things I'm going to talk about, augmentation and synthetic data, are ways to kind of stretch the data that you do have when building a data set to kind of make it go further. And then, as I've talked about in other Hacky Hours, it's important to have a well-balanced data set, so where you have kind of around the same number of each of the classes that you're going to inference in. When you're talking about object detection models here. So we have a class balancing script, and then for various uses, you might want to test your bounding boxes. So I'm going to share a script that deals with that as well. So to get started, let me talk about augmentation. So the data set is one of the most important parts of training a model. The old adage of garbage in, garbage out. It relates to the number of images, the number of examples of each class that you have, and sometimes it's hard to gather enough data. Whether it's a situation that you just can't do it, or a time, or rare, if you're doing animals, rare animal species, I don't know, for whatever reason you don't have enough data, augmentation is a good way to kind of stretch your data and give you more examples of that. It's also, it's pretty common. A lot of times the augmentation tools are built into your framework. PyTorch or TensorFlow kind of has their own custom augmentation tools, and then there's also various libraries. I'm today going to be talking a lot about ImageAug. That's kind of the library that I use, but there's multiple others. Augmentations is one. Augly is a new one from Facebook I haven't checked out. Augmentor, and these are widely available kind of free libraries. There's a lot of documentation involved in those. And so you can kind of fit one that find one that fits your use the best. But we're going to be talking about ImageAug today, and here's just kind of an example of the different augmentations that you can perform. So you see here, this is augmentations based on one image of chipmunk or groundhog. You could see there's simple ones of just rotating, resizing, or cropping, and then you can get more advanced ones of adding noise and blurring, kind of shifting the color balance, shifting the contrast, shifting the brightness, and you can really get kind of creative with the augmentations that you perform. Keep in mind always that you want to perform augmentations that are realistic to the environment that you're going to be inferencing in. So for example, if your data set is all bright light and your model is going to be performing in a daylight or bright environment, then you might want to not go with darkening or reducing the contrast to get your picture dark, because you're just not going to have examples. On the other hand, if all your data set is daylight and it's going to be a night and day inferencing model, then you might want to darken the images, kind of, but changing the color balance. You can get dusk-like images like this one, or sunrise. And then for creatures like this, if you go for motion blur, then that's how animals act. So if you kind of do some blurring, you'll find that when you're inferencing, you might need to inference something that's moving, so blur is realistic. Whereas in other situations, if you're inferencing static objects, blurring might not be the best choice. So this is just kind of to show you the different augmentations that are possible, and all the different third-party classes that I mentioned kind of have this wide variety of augmentations. You can see if you look here in the number, they can be made more extreme or just slightly augmented. But we kind of pay attention to which ones you're choosing, because ones, kind of like this one, this is the same image, it's not going to benefit your computer vision model. So this is kind of an idea of the different ones, and now I'll kind of go over the script that I provided and how to use it. So the first thing you need to do is go to GitHub and clone our data set management tools. We'll provide that link following this Hacky Hour. But in here, we provided you a number of things. This is the Augment Images script, class balancer, which I'll go over, the testing annotations, which I'll go over. Label converter is straightforward. I'm not going to go over it today, but we've included that. And then synthetic objects. This is where we're going to kind of put, kind of create images using synthetic data. But first, let me demonstrate the Augment Images. And so what we did with this was we took kind of some classic and straightforward augmentations and built them into this script so that you can call them just using a flag. So here's a list of the ones that we use. These are also included in the tutorial, but they're pretty basic, rotate 180, darken, and then kind of combining these together. Darken and rotate, blur and rotate, grayscale, kind of zooming in, but nothing too extreme, but kind of even this mix of augmentations will really enhance your data set. So I'm going to show you the command in a little bit, which is pretty much just running this Python script with the input directory, which is where your current data set is, and the data set being a folder of your images and a folder of the annotations for those images in Pascal VOC format, and that is zipped together. And then you can use a number of flags. But before I do that, let me just kind of show you where you can customize this a little bit. First, just the the straightforward customization is all the brightening, darkening, kind of zooming has number values associated with them, and changing these values here is going to, zoom in or out, usually with one being kind of the default. So if you, for example, on the brighten here, if you change these values 1.4 and 1.6 to 1, then that's just going to be the default brightness of the image. The higher the number, the brighter it's going to be. The lower the number and getting below 1 is when it's going to start to darken it. So as you can see, if you use all of these built-in augmentations, or I guess augmentations that we've included in this script, you can multiply your data set by 15 or 16 times. And then the other thing is you can look at the documentation included with ImageAug, and that's where you can get some of the more advanced augmentations of adding noise or really dealing with the color balance or contrast. So let's see. Just for demonstration purposes, I have made a data set here. It's just 4 images and their associated annotations. Again, in Pascal VLC, and I've zipped it up into this zip file, and I am going to now augment all these images. So we're here, and make sure, so I'm running this just Python Augment Images .py, but I am in a conda environment that has ImageAug installed. So that's kind of the one requirement when running it, that you have the library ImageAug installed in your on your machine. So the arguments are the input directory, and that is what I copied, and then you put the number of augmentations that you want to do. So there was blur, there was zoom, and you just put as many or as few as you want in there. Just for demonstration purposes, I'm just going to run all of them. And this will kind of tell you which augmentations are being performed, and then it's going to run through all your files. And this is relatively fast because I just have 4 files here. You could see with a large data set, if you got a couple hundred, it might take a while. So we're done here, and let me kind of show you the results of that. So that is created a folder here. Zipped it back up, ready to be used. And again, in that annotations and images folders, and you could see here that what it does is it creates new images, kind of changes the name of the image to reflect the augmentation that has been performed, and then does that for every image in there. So you could see here we turn 4 images into 72 images. Let me get kind of close up, and it will have the same augmentations for every image. So we are kind of varying the rotation of them, varying the brightness, the grayscale, the blurriness, zooming, and it really gives kind of images with more information to use in training your model. In addition, it also generates the associated annotations in Pascal VLC format. So it's got the name, and it changes, the inside file name. So that really saves you a lot of time if you want to, again, stretch your data set to quickly get more examples. Is there any questions about the augmentation portion?
Not so far. I think we're doing good.
Okay, great. Next, I'm going to talk about synthetic data. So synthetic data is something I'm really excited about, mostly with the goal of reducing the need to annotate your data. That's one of the, the major pain points of collecting and crafting a data set is annotating each and every image, especially if there's a lot of objects on there. If there are small objects, it can just get really tedious to annotate everything. So I started looking into synthetic data, and I started out looking into Unity. They have kind of I think it's kind of new, like their perception engine, which is meant for object detection, computer vision models, and it's a way to have fully synthetic data. And their tutorial, which I went through, uses kind of grocery items, a list of grocery items that they've made into assets, put on synthetic backgrounds, and it works pretty good. I have the link to that in the tutorial, and it's a fully synthetic option. The issues that I had with it were kind of the learning curve of the Unity engine, of the interface of generating assets, is time consuming and kind of not really what my background's in. So if you have a background in video game design or something, it may be a better option for you. But I wanted a way to kind of create synthetic data without needing to go through Unity. So the way that I did that is through this script here. And what I'm doing is I am taking examples, collecting examples of the objects that I want to inference on, and removing the backgrounds of those objects so that they become an asset that I can then synthetically place on a background. This works relatively well. The limitations are the number of assets that you can have for each class. So I'm going to show you a couple examples of those. Where are we? And yeah, and there is okay, and there is some time to generate these assets also is kind of time consuming, but you'll find that as you want to build the data set, the upfront work, the work is really upfront in creating the assets, and then you don't need to do any of that annotation on the back end. So included, let me just kind of highlight here, the included in the scripts is really just these two, the synthpy and the result.xml. And since I was the one who wrote the script, it's not very elegant, so you're gonna have to create a couple of folders to help you with this. You need to create the JPEG images and annotation folders. That's where the output of the script is going to go. And what the script does is it looks for a folder called backgrounds, and this contains the background images that you use. In this case, the more the better. Try and fill this up with background images that are representative of the environment that you're going to be inferencing in. So if you're going to be in the jungle, get jungle background images. So this is, it's good for if you can't get out and capture data in the environment that you're going to deploy your model. You can find images of that area. You can augment those images. You can try and get a large number of background. That's really going to help out the robustness of your model. But this is where these are the kind of the base images that we're going to put the assets on, and the assets go in a class, this classes folder, and there's folders nested in here, and each one of these folders is a class of objects that you want to detect. So I kind of after going through the Unity and seeing their grocery kind of demo, I went to the convenience store and kind of got snack food to try and continue that. So that's what each one of these is. And what you have in here is just the image, and I can't tell you how I did that. You just, take the image and remove the background. And, Photoshop is the classic way to do this, but PowerPoint also has a background removing tool. Preview is where I started doing it. Any kind of image editing tool. And let me just walk you through what I did, because there's a couple things to keep in mind here. So this is one of the original photos that I used. I just took it with my cell phone, and then my process is cropping it. Cropping it is pretty important because we're going to use this as the bounding box. So you need to crop this object as if you were drawing a bounding box around this, and in a labeling tool. So treat this as a bounding box in CVAT or whatever labeling tool. And so now when we place it on there, this is the area that it's going to go in. And then I just here use a smart lasso to remove the background. I'm not going to, usually I'm a little more careful. We just invert selection and delete, and you can use this and really delete it. But generate assets, if you want to get more advanced, I'm looking into green screen so that we can programmatically remove the background and other things. But the important part is to crop the image so that it's as a bounding box. And then when you save it, you need to export it as PNG or a format that has the alpha channel. Otherwise, if you do a JPEG, it's going to fill in the non-pixelated parts with a random color, I think white or black, and that's not going to work for when we superimpose. You will see, so since this is something new that I'm experimenting with, I do have a couple examples of the classes where I did not go that extreme as far as getting rid of the background. And my goal is, we've got some advanced model analysis tools to see if the classes where I really get really have good background removal do any better than the ones that kind of have the have some of the background associated with them, and how the model is going to look at those. And I assume it's going to depend on the background, how it differs from the actual background. So if it's uniform and you keep some of the background, it's not gonna make a big deal. But if it looks like someone standing in a cityscape and you superimpose it on a jungle and you don't take out the background, the model's gonna not perform super well. So I'm still kind of playing with this, but that's how you create the assets. And then run this XML is just a template for the XML, and then running it, you just set the number of images that you're going to export. I'm just going to do 30 here, but you set it for 3,000 and you have 3,000 different images. And what it does is it looks in those folders, it takes a random background, and then it looks in the classes folder and takes random classes and puts them on there. The logic that I did with that one is right here. So I use 1 through 5 classes, but you can set this, and if you want to put on 10 or 20 different objects in the same image, you can do that. The caveat is occlusion. So I don't have any logic if you place one object directly on top of another. Both bounding boxes will exist, but the object on the bottom will not be visible because it'll be completely occluded. So I don't have the logic to kind of prevent that. So what I did was I kind of separated the image into 6 sections so that objects can be next to each other, but trying to reduce the overlap. So this is kind of logic that I want to play around with to be able to easily put more objects on a single image and kind of be in more control over the occlusion. So anyone, feel free to, send your ideas on that or make any changes, and then it just exports the image and exports the XML in Pascal VOC format. So let me just demo that. So let's see. So we just run this, again, just running and making sure that you got image aug, and then this is just lazy print statements that I haven't deleted, just to confirm that they're the number of objects per image and that they're sufficiently separated. So you can see it just starts putting out images. Did I forget to save it again? Looks like I forgot to save, changing it from 3,000 to 30. So I'll stop it so we don't have 3,000 images. But you could see, why don't I do this? That it just generates images of the convenience store items, kind of throws them on there, and you can see that some of them are better than others, both in positioning and in the removal of the background. But I'm really kind of just running through this experiment to see what works best. But the nice part is you've got images and the associated annotations that are all ready to compress and train with using the alwaysAI model training platform. Any questions? Any questions about this part?
I had a question actually, if that's okay.
Yeah, absolutely.
So for like bottle, do you just use like one image of the bottle or like a certain object, or is there like multiple versions of each one? It's just like one image and then it just gets transposed or moved around in the image?
Right, that's a good question. So for kind of like all data collection, you try and get as many different permutations as you can. So since this
Cool.
is different objects, I set up a scene and would place the bottle, you kind of moving the distance from the camera in what is reasonable, spinning it around so that we can see all the different sides. This one's a little blurry. See all the different sides of the label, different angles, but trying to get the words, trying to get the logo, and really just try and get that variety. So right now I have about 20 to 30 per class, and I'm running experiments to see if that's good enough. Where I want to expand in the future is running the augmentation that I showed at the beginning on these assets, and that way, the variability of light and shadow can be emulated through contrast and light augmentations, and that will turn these 20 or 30 examples of the assets into 60 or 100 examples of the assets, and then as you mix them with the other ones, you can start to get a pretty robust and diverse data set to improve your model, is what I'm thinking. The problem I've run into so far is I haven't found the augmentation library that respects that alpha channel. So
I was just wondering that, if you had to do it before you move the background, because that would, like, if you did like for brightening or darkening, then that would quadruple your work for the background subtraction.
Right. Right. So with the goal of reducing the annotation work, it's not going to make that big of a difference if I just replace it with background removal work. Both are tedious and not fun. I'm thinking as long as the background's a solid color, then programmatically removing it is more straightforward. And I think we can develop a script for that. So where we remove the background, augment them, and then programmatically remove the background that has been reintroduced in the augmentation process. The problem I ran into there is that the color is usually black, and you can't just remove all the black because black is a pretty common color.
Yeah. Yeah, that's interesting. Yeah, that sounds like fun though. I bet we could do some cool stuff with that.
Yeah, I'm excited to keep building out the capabilities.
Yeah. Cool. Thanks, Todd.
Yeah, absolutely. So that is synthetic, and you can see how there's thoughts of it working with augmentation, and then to transition into the next phase is class balancing. So you saw the script where I just kind of randomly pull classes, and you would think if kind of like flipping a coin, the more images you do, the more likely that the result of that is going to be pretty well balanced. As long as the number of classes is the number of examples of each class is relatively consistent, then you would assume that the distribution of classes in the final data set is going to be relatively consistent. But this is kind of synthetic data. What about capturing data in the wild, or you're set up a scenario where you're collecting data? How do you make sure that your classes are balanced? So we've got kind of a little script just to run through that, and this was written by Shesh, and I'll show you how it works. So again, this one, like most of the other ones, is assuming you have a data set. So you've got images and you have their associated annotations. Again, in the format of folders with titled JPEG images and annotations. This one is not looking for a zip file. And this is going to parse through all the labels found in those annotation files and count them up and present them back to you. Taking that a step further, you also have the choice of it's gonna tell you the best achievable balance, which is based on your current images and their associated annotations. How can you manipulate that to have as close to a ideal distribution as possible? Excuse me. Ideal being the same number of examples of each class, and it's going to tell you what images to remove from your data set to get a better distribution. And then also there's an option of partitioning it where you're going to take those images out. So let me show you how this works. And another thing that I want to mention is you can define the allowed imbalance, and that is, it's especially in the real world, it's not possible to have the balance be perfect. This is default is shooting for that, but if you change this imbalance, then it's not going to partition. It's going to give you that buffer of your distribution. So I'll run this a couple times. So I put the data set here. So what I did was take the synthetic data output, which was, I did 416 items. And this is just to have a demonstration of the distribution. So this is that same demo that I just ran, but running with 416, and we'll see of those, about 10 or 11 objects, what is the distribution of them. And the other thing to consider with this one is the other things I've demonstrated are just scripts that you run, Python synth.py, but this is actually this class balancer. I'm giving it to you. Sorry, I'm giving it to you as a script here, but to run it, it's got to be run through an alwaysAI project. So in the tutorial, we've got links to how to create a blank alwaysAI project, how to point to the class balancer py instead of the app.py, and that's just what I've done here is through the alwaysAI app.json, just having on startup running class balancer.py instead of app.py. So see, I've copied so now I'm in that class balancer project, and I do AI app start. And so again, we can run through this. I'm kind of assuming that we've run alwaysAI apps, but if you haven't looked through the documentation, you just need to run alwaysAI app install before this. And then we do -- and then we do -- input directory, and see if this is underscore or not. Maybe it's, maybe I didn't get the latest. So what we have here is kind of three outputs. The top output is the distribution of your current classes. So you can see, we got the Diet Pepsi, Deep River chips, and it displays them from the least common to the most common, or the smallest number to the biggest number. You can see it ranges from 85 to 139. That's kind of to be expected. You expect it to kind of even out as we run it, but you can have if you're just sourcing images from the wild, or your data set may be way different than this. So there's a couple things you can do with this. So you can look at the best achievable balance, and this is based on your current images and your current annotations. How can we get the closest to equal? And this is saying with this bottom one, saying if you remove 106 of your images, then you can get a balance that ranges, instead of ranging from 85 to 139, looks like it ranges from 81 to 85. So that's a much more equal, but you are kind of removing images. Now, we thought of that's fine, especially if you're I guess we thought of the complaint that especially if it's hard to source data, or you already have these images, getting rid of them is not ideal. So you can use the images as test images. You don't necessarily want to use them as validation images, but you can keep them for testing purposes, or you can just look at kind of this initial distribution and then try and add take more pictures or add more data to make it more balanced just by looking at that. Now I forgot the command to partition. I think just partition, right? So now I'm going to show you what happens when you partition it. And this output should be the same thing here. It's slightly different just based on rounding, but then what that does is in the place where you're running it, it will hold out the images and annotations. So 107 and 107. It doesn't delete anything, but it just kind of rearranges your files so that that using these two and compressing them and training them on alwaysAI model training will have the most closer to perfect distribution. I'm going to quickly, I'm running out of time, just show you the test annotations pie. And what this does is it just plots the bounding boxes of your images, but again, based on Pascal VOC annotations. And this is just kind of a sanity check. You know, if you're using synthetic data and you export from Unity, it's a certain format, and if you put it into Pascal VOC, you might want to check to make sure that the boxes line up, which can be a tedious process. If you're doing any other sort of data conversion, or I've had issues of the EXIF data and the rotation in CVAT and it's either respected or not respected, and just the annotations don't line up. So if you're training your model and you're not getting the performance, something that I've had occasion to do a number of times is just kind of sanity check the annotations, just to make sure that they're plotted right. And again, this is looking for a kind of an alwaysAI data set annotations and JPEG images, and it's just gonna plot those images for it. So I'm gonna get this path and run this command. I'm not sure if this is the right input directory, so let me just repaste it. Something that I'm not demoing, because this is just for images, is the sampling. So if you add the flag sample, when you run that, you don't have to plot every single image and every single bounding box. You can just do 1 out of 10. If you do sample 10, you can do every 10, and that if you have a data set getting into the thousands, you're not going to need to see every single annotation on every single image. But this, we can see that the vehicle has been labeled. It's got the label there and the bounding box, and just kind of know that that these annotations have worked. So that's what I have. Lizzie, we can bring back up the slideshow. I could take questions if we have any questions.
No, I think that's great.
Yeah, great presentation, Todd. Thank you all for sticking around to the very end and participating in today's Hacky Hour. If you have any further questions about the presentation or the demo, you can email us at contact@alwaysAI.co. And if you're interested in seeing our product in action, our team loves to do demos. You can schedule a demo by visiting alwaysai.co/schedule-demo. If you'd like to watch this Hacky Hour, again, it will be available on our blog